Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we'll learn about the graph of 1 over x squared and its related functions. So this has some things in common with the graph of 1 over x. For instance, it does have a horizontal asymptote at y equals 0, and it does have a vertical asymptote at x equals 0. So again, horizontal asymptote at y equals 0, vertical asymptote at x equals 0. But the way it's graphed is a little different. So first, the squaring part changes how quickly it rises or falls, but also squaring makes that denominator non-negative. So this graph for this function will be entirely above the x-axis. Let's start with a table of values. So we're looking at x and 1 over x squared. So when x is 1, we've got 1 over 1 squared, which equals 1. So it has that same point. When x is 2, we get 1/4 or 0.25. So when x is 2, it's going to drop down even faster than the 1 over x graph, which went down to 1/2. 1 over 4, when x is 4, you'd get 1 over 16, almost touching. So I know as it heads to the right, it approaches that, but never touches it. Now to the left of 1, say we took 1/2. 1/2 squared is 1/4, but 1 divided by 1/4 equals 4. So when x is 1/2, y is 4, and we see that it's going to shoot up really quickly on that side. Now, zoomed in like this is not very smooth, but I'm sure he'll do a better job. The points on the other side are mirror images. So this is symmetric around the y-axis, because when we put in negative x, we get the same function out. So I'm going to just use symmetry to put a point here at negative 1, 1, at negative 1/2, 4, and at 2, 1/4. And zooming out, that's the shape of the 1 over x squared graph. The domain is everything except for 0. You can plug in any number you want except for 0. The range is a little different than the 1 over x function though, because not only doesn't it touch 0 for y, it doesn't drop below that either. So the range is just 0, infinity. Another place where this function family is different is when we talk about intervals of increasing or decreasing. So on the left-hand side of 0, this is increasing, right? It's going up to the right. But on the other side, it's decreasing because it's going down to the right. So intervals for increasing, negative infinity, 0, decreasing, 0, infinity. So basically, it's increasing on this first interval and decreasing on the second. If this function can be shifted left, right, and the asymptotes will go with that shift, it can also be stretched. And when the stretching factor is negative, this is going to flip over the x-axis and it will head down like this instead of up like that. Let's do one example that's got a little of all of those features in it. We're going to graph f of x equals negative 3 over x plus 1 squared plus 2. So the negative tells me, I'll keep going with red, that we're going to reflect across the x-axis. The 3 is the stretching factor. K is 2, so that tells us we're moving up 2. And then finally, h equals negative 1, so that's 1 to the left. And the reason that h is negative 1 here is that this is x minus negative 1. that's being squared. So what are we subtracting from x? We're subtracting -1. So I'm going to begin with, and actually this time I'm just going to use the red pen for the asymptotes. So I've got 1 at -1. That is the vertical asymptote, x equals -1. The horizontal asymptote gets shifted up 2, so that's going to be up at y equals 2. And already I know that my domain is everything except for -1, but my range, I don't know if this is going to be graphed above or below. And actually it's going to be graphed below because of the reflection. So we're going to be working in the bottom 2 quadrants. Let's start with some values for x. And I'm going to work on the right-hand side. Then I can use symmetry to get the left-hand side. So the function I have, -3 over x plus 1 squared plus 2. I would like to divide -3 by a number that goes into it, but that square is kind of a problem because I need the square to divide into 3, and really the best option here is when the denominator is 1. And that's going to happen when x is 0. We're going to have -3 over 1 squared plus 2. That's -3 plus 2, or -1. So when x is 0, y is -1. If we try x equals 1, we're going to have -3 over 2 squared plus 2. That's -3/4. And so -3/4 plus 2 is 5/4, or 1 1/4. And so when it was 1, we're up at 1 1/4. And I can start to get an idea for how this is going to go. It's going to go like that. Then I can use symmetry on the other side. The first point I graphed was 1 to the right of the asymptote. So I'm going to put another point 1 to the left of that. You can plug in -2. You'll see that you'll get the same thing. The second point I graphed was 2 to the right of the asymptote. So at the same height, I'm going to go 2 to the left. And there we go. Domain is everything except for -1. Range is everything up to but not including +2. So the range goes from -infinity to 2. And we use parentheses there because, again, it doesn't touch 2. It gets close to it without reaching it. Where is the function increasing? It's increasing on the right-hand side. So increasing from x equals -1 to infinity. Decreasing is on the left-hand side. That's everything up to but not including -1. Like so. All right, those are a couple of examples of the function 1 over x squared. In the next video, we'll start talking about slightly different rational function graphs.